We're doing an example in chapter 4 now, which I think I have not done before. And there's a pretty simple, but a bit confusing until you get the hang of it. Let me share my screen. Let's find the example. It's chapter 4, number 10. I've done a number of other similar examples, but not this exact one. And we have some data, and you like to calculate the mean, the standard deviation. That's easy in Excel or StatCrunch. But then they want you to calculate a z-score. So it's easy enough to do this by hand, or we don't have to do it through Excel. So let's copy the data into StatCrunch. Let's get the summary stats of the two columns, send housing, hitting shift to get both of them. Nowhere, we want the mean and the standard deviation. So we can get rid of some of these things, but it doesn't hurt. Let's have them all. Okay, so let's see. Ooh. Housing has a mean of 72485. That's it. It has a standard deviation of 23380. That's correct. And housing has a mean of 99, which we see here. And the numbers are in percent, so the answer is 99% technically. And a standard deviation of 140.54. That's where these numbers come from. Now, then they ask you to calculate a z-score. Well, a z-score, which I don't think you can do in StatCrunch, is simply, well, I'll give you the formula, and then we'll calculate the formula. The z-score is equal to, for Columbus. Oh, so we're going to need the data again. See if the data is still there. Yes, this we don't need. This was an old problem. All right. This we don't need. We don't need this, or this, or that. Hold on, where are we? I think I'm going to have to open up the data a second time. This is the data. So we want it for Columbus. Well, Columbus has a value of 54,578. Okay, they tell you that. And New York has 136. It's always bigger. Okay. Now, convert this number into a z-score. The z-score formula, which you can, of course, see from Help Me Solve It or reading the book, etc., or looking at my videos that discuss z-scores, is equal to the number that you're trying to convert to a z-score minus the average, so it'll be 54,000 minus 72,000, divided by the standard deviation. So that difference, which is negative, is going to be the z-score. And basically what it's doing is telling you how much, by subtracting the number from the average, you're seeing how far it is from the average, and dividing by the standard deviation gives you a sense of how many units of standard deviations we're talking about. Because 1 unit of standard deviation is, we know, according to the empirical rule, contains 34% above it, 34% minus. Anyway, it's a measure of these numbers in a kind of a unitless scale, because the numbers on top are these numbers at dollars, the numbers on the bottom are dollars, so the units cancel out. So let's do the calculation. How much is the number starts up 54,578 minus 72485.87 equals divided by the standard deviation of 23380. 23380.97 equals minus 0.765, or really minus 0.77. We can put a minus, let's see that. Minus, very important. Got the answer already myself. 0.765. Try it again. Minus 0.76. New York, by the same calculation, is going to take the number for New York, which was 136, minus the average. This time it's above the average, and divided by the same standard deviation. So it's 136,024 minus the mean of 72485.87 equals positive 63,000 divided by 23380.97 equals positive 2.717 or 2.72. So 2.72, when that's telling us it's 2.72 standard deviations above the average. And it works. Now they tell you to go through the same thing with the other variable, which has a different average and a different standard deviation. And I'm not going to do that now. It just happens to be very late at night, but that's not your problem. But I believe that's all they ask you to do. Oh, then they ask you for an interpretation. The z-scores show that the comparative salary amount for New York is farthest away, because you look at this, the bigger the z-score, okay, this has a z-score of minus 0.86. This has a z-score of 2.67. Ignore the minus sign and just check the size of the number. Well, whichever is bigger, New York is bigger. It's furthest from the mean, not just in absolute units, but also in terms of how many standard deviation units. So these scores also show that housing units for New York is, let's look at the z-score for the housing units. Here it was, I'm sorry, we just did that. And here it's, again, minus 86. Forget about the minus sign. 2.67 is greater. So New York is higher. In both cases, furthest from the mean. And we're done. Okay, stop sharing. Exit out.